So this is session 4AV. So if everyone can make sure you make a note of that and fill out your session feedback with that number, and we'll pop that up at the end as well, so you can give your feedback. So we have Soumya from IBM in California. So it's bright and early at the moment. So, I mean, I assume she's probably more awake than I am right now anyway. And she's going to be talking to us about Datagate, current and consistent Db2 for zOS data on any cloud. So I'm very interested in this. I don't know much about this myself yet, so hopefully going to learn a lot. The session is going to be recorded and will be available after the conference. And if you've got any questions, please ask it in the chat window, and I'll ask it either as we go along if it fits in time-wise, or I'll ask them at the end. So with that, I'll hand over to you. Thank you.
Sophie. Welcome, everyone. Like Sophie said, the sun has still not shown its face yet, but I'm looking forward to presenting this to you guys. It is a new topic, and it's an up and coming technology. So I'm very excited to share this to see what you guys think about it. So let's get started. So I'll just skip over these two slides. So here's what I have planned for you guys today. We'll start out with an introduction on what Datagate is and what is the business case that drives Datagate. And we'll do a demo. We'll see things in action. And then we'll come back to the presentation mode, and I will do a technical preview or overview of some of the key elements of this technology that powers Datagate, and also share some performance measurements and what's new in the last couple of releases that we've had since this summer. So to start with, I do believe many of you may have heard about Cloud Pak for Data, IBM's cloud platform. And Datagate is one of the services that is built on top of IBM's Cloud Pak for Data. And so what that means is it runs on all the platforms that are supported by Cloud Pak itself, which is private cloud, Linux on Z, which is on the mainframe, Intel-based bare metal, VMware-based, and public clouds like AWS or IBM Cloud. Now, the claim that we have here, and I'm going to start covering this from a product perspective and then jump into the technology that powers this product. And I believe that is the meat of the presentation. And so, the claim here is Datagate makes data from Db2 for zOS consumable for cloud-based applications. What does that really mean? So as most of us know, that Db2Z has one of the largest footprints in the enterprise database world. And this also means that a majority of the business critical data that enterprises have resides on Db2Z. And these days, with the spike in the application development trends, there is need for reporting applications that require read-only access to the transactional data that's on Db2Z, as well as analytical applications that require access to historical data. And the need for data to drive these new, possibly cloud-based applications does not in any way eclipse the need to keep the existing business critical applications that are most likely on Z itself, continuing to need timely and reliable access to the data that's on Db2Z. Some organizations have actually built custom extract, transform, and load ETL jobs to make Db2Z data available on the cloud. While this may look like a good short-term move, there are concerns with security as soon as the data is moved off the platform. And in addition to that, there is always a concern about increased cost of these solutions on Z, MIPS usage, and in general, expensive maintenance over time. This is one of the areas that Datagate's core value prop is rooted. making it easy for new applications on the cloud to access mainframe data on DB2Z without impacting any of the existing mainframe applications or any other applications that already access data on Z. So a quick overview of how this is uh, designed or architected is on the left side. You see the traditional applications, the ones that exist today, and HTAP applications running undisturbed, and they are still able to access data on DB2 for zOS using the way they usually do, SQL request result sets passing back and forth. Now, where DataGate comes into the picture, we also see this piece called Integrated Data Synchronization Protocol right in between. And that one is the secret sauce to the whole mix here. And DataGate as a product is driven by this integrated data synchronization protocol, which helps synchronize the data between DB2Z and DataGate. DataGate runs on the platform, Cloud Pak platform, and it can use a target database that is either a DB2 warehouse on Cloud Pak for Data or a DB2 advanced edition on Cloud Pak for Data. And once the data is synchronized from DB2Z into one of these flavors of DB2 Linux, Unix and Windows, then any cloud-based applications that are either they're running within Cloud Pak for Data, business reporting, you know, other ML, any AI applications that are built on the platform can now continue to access the data using the target database. And this is kind of how things are wired. So at this time, I'm going to stop the presentation and I'm going to jump into a live demo. I would need to stop sharing this screen and start sharing the other screen. Okay. So some of you may be familiar with Cloud Pak for Data, some of you may not. So I'm just going to start with the dashboard, Cloud Pak dashboard. So this is the services catalog.
I think we're looking at the wrong screen. We can still see your presentation.
Oh, thank you, Sophie. Okay, I hope.
Yeah, that's right.
Better now. Okay, thank you very much. So let's start out then. So this is the Cloud Pak for Data dashboard, and as I'll start out with the services catalog. So this is the catalog of all services that are supported by Cloud Pak for Data, and let me just go to the data sources. That is where DataGate is. And for all those that are installed currently on my cluster, I do have a few services installed. You will see this enabled section right here. And clicking on this, you could read something about it, go into the launch into the documentation. And the other ones are you could create a new instance of DataGate or look into the existing instances. So let's just start out with this flow. I am not going to provision one, but just to give you an idea of how things look like. So one of the first steps when creating a data gate is to select which target database the data is going to be synchronized to from DB2Z. And in this case, you have an option transactional analytical. I already have one provision, so it's likely not going to show anything. And this is to select how much CPU and memory you want this particular service to be allocated in your cluster. And some details about storage, either create a new storage or existing, which namespace you want this to be running into. And for those who may be familiar with the way Kubernetes runs, projects do run in namespaces. So, and the route, this is basically the DNS name of the address that the source is going to use to communicate with this service. So this is how the provisioning looks like, and it typically takes about 5 to 7 minutes to sorry, 5 to 10 minutes to provision. So I'm just going to launch into one of the instances that I already have created, right from this list of instances that I have on my cluster. So I click on open, and this is going to take maybe a few seconds to run. And what it is going to present us with is a dashboard. This is the DataGate homepage or dashboard. And let me just briefly go over some of the elements that you see here. So this is the name of this DataGate instance. And that, as you can see here, the target we use here is a DB2 OLTP. And I will get into that when we initiate some data transfer and then go into the look at the dashboard. So this is the part that is telling the source for the data gate. And what define source means is you tell us which DB2Z you want to use as the source. And in this case, I am using a subsystem, and this is the secure DDF port. I will discuss a little bit more in detail, but all the communication uses there is security built in by design. We do use the secure DDF port to communicate. And so this is the standard JDBC parameters. For the log reader, this is the component. Again, we'll be talking about it more in detail later. And the log reader, you again provide the details of the log reader and the certificate to use for the encrypted communication between DB2Z and DataGate. Once this is done, the next step would be to start out by selecting which are the tables for which you want to synchronize the data between the source and the target. Now, just before that, let's take a look at the two graphs that you see right here. And so what this means is, since data is moving between or getting synchronized between the source and the target, there are two metrics that we present here. One is the synchronization latency in seconds, to tell us how many seconds, how much latency is there between the data transfer. And in this case, I didn't initiate anything, so you don't see much activity going on. And the throughput is how many rows per second of data has been transferred from to the target. The next part is the list of tables. And here you can see there is also a quick overview of all the statistics, table statistics. And active means that the data has been added, the table has been added, loaded, and synchronized, enabled for synchronization. Loaded meaning the table has been added and loaded, but it is not enabled for synchronization. The initial load has happened. Loading means, of course, it's in the process of loading. Load pending means as something, either it's queued or something else is holding it from the load. And error means something went wrong. Either the table might have been corrupt or not the right format, other things. For this section here, so we'll start out, let's just take a look at how the add table process flows. So assuming when we do the add table, it is pulling all the schemas from your source. So assuming I have I have a loan application. So here we'll pick a loan demo, and I have a look at all the tables that are in the schema, and I choose to just load 3 of the tables. And the part here to remember is not all tables need to be loaded from the source to the target, and only what your application needs for access needs to be loaded. Now, this toggle that you see here to enable synchronization and load tables, what that means is when this operation, when I click on finish right here, it will proceed to add the tables, meaning it will create the table structures as it is in the source into the target. It will enable synchronization, meaning it will turn on a switch. that says I want data to constantly keep getting synchronized between my source and the target. And also the third one will be loading the initial load for the initial data load for the table. So I'm going to click finish, and you will see, you will see either it succeed, or if it didn't succeed, an error message indicating why it didn't succeed. So here you can see there are 3 tables in loading state, which are the newer ones that we just added. At any time, if you did choose not to enable the synchronization and load, you can always come here and click to load the table. And also, since this is enabled, you see the disable, but if it's not, it will see an enabled synchronization from here. And so this is how the data gate dashboard looks like. A lot of the complexity is hidden behind. We've tried to keep it as simple and straightforward as possible to the end user. So you don't have to, the user does not have to select through 10 different options and choices and all of that. We've optimized all of that in the background to make sure that the throughput is high and it's extremely performant. So you can see one of them, finished loading. So let's go here to the target, and I want to give you a view of the target dashboard. Um, just to see how to monitor things. If I did have an application, you could always run the application to make sure that the data is getting synchronized, data is current between the source and target. So I'm going to click on the open database right here. Hopefully it doesn't, uh, it comes back fine. But the systems did go down for maintenance. So I'm a little, I tried this a few times last night. So, okay, that's good. So it came back up. We'll just give it a second to finish loading. And when it loads, you will see a lot of metrics right here. And this is, so this is the input output. So you see here, there was not too much data on the tables that I at least loaded. So you do see a minor spike here, and there is also some other activity, SQL activity that's been going on in the last hour. So this is one of the ways you can monitor your target database on the that's running inside the Cloud Pak for Data ecosystem or platform. So I am going to move on to another, another cluster where I have another data gate set up, and this time I do have it set up against a Db2 warehouse. And one of the differences between the two, the first one that we saw, which was paired to a Db2 advanced edition, and this one, which is using a Db2 warehouse, is this particular Db2, the DataGate instance, is also enabled for query routing. And what that means is, for those of you who are familiar with IDAA, it is one of the core business value of IDAA itself. And the idea is to be able to use the same concept of query acceleration from IDAA in DataGate, wherein the difference would be that the queries would now be accelerated onto this DataGate and will be running against the target database that is running on the cloud or on the cloud platform. And otherwise, conceptually, they are same, but the user interface does have a few different elements that I want to talk about briefly. And just a reminder is that this query routing feature, we will also see it in the What's New section later, but this feature is in technical preview currently. And we do plan to go out with it GA sometime very soon. So this is, you can see the difference in the dashboard layout here, and that's because we have more information on the left pane. Okay, that decided to flip on me for whatever reason. Let me try this again. Sorry, please bear with me for a moment. Yeah, anytime systems go down for maintenance, I'm always wary, but I think we just have to run with it. Okay, great. It did want you guys to also see it. Okay, most of the important information remains the same. You do have the data gate name. In this case, the target is a DB2 warehouse. This is the DB2Z source that I'm working with. Here you have the data gate status, which says it's active, as in the engine is up and running and it's been it's working fine. The synchronization is working fine. It's still working. Okay, so the query acceleration status in this case is started with the ability to stop and start in case of maintenance needs. You don't want to accelerate queries. You can come here and stop the query acceleration at the data gate instance level. And some metrics here that says how many queries are, query statistics, how many queries are active, successful, active, queued, and failed. And in this case, you see the tables that not much has changed in the table data itself, except that there is an additional column here for acceleration, indicating if acceleration has been enabled at the table level. And what this means, the difference between acceleration at data gate level and table level just means that if you do stop acceleration at the data gate level, that means that this data gate is not going to serve for query routing. Uh, but if you do have that on, you can choose to decide which of the queries queries that reference which subset of the tables you want to be accelerated. So that is where this toggle switch allows you to control. So in this case, I do have the ability to start and stop right here. But an addition is in the add tables, we talked about 3 steps, which is creating the table structures on the target, enabling synchronization, and loading tables. There will be a 4th step here, which also toggles the acceleration on and off. So this is some of the queries that I ran in the past, last week actually, and it does. If this is queries that these are queries that have been accelerated from DB2Z, that were submitted to DB2Z and have been accelerated to this data gate instance. And in this case, I can select a query and I can say, show me the full SQL text. That should come up momentarily. And yeah, so it's a very simple query that I have there. But these are some of the additions that we are working on. And during the provisioning process, you will see an additional, if I do choose DB2 warehouse as my backend or target database, I will have an additional field that says, do you want to use query this as a query accelerator? And yeah, so this the latency and throughput, none of that changes. It's still the same that we discussed previously. So this is the demo I had planned. I am going to stop screen sharing and go back to the presentation. Okay, let's go back here. Great. Okay, so this is what we just saw. This is for the. Okay, so let's look into some of the internal aspects of this. So we all know that security of the data is key to all of our users. So let's talk about some of that here. And we saw this in the demo. all the communication to DB2Z goes through secure JDBC port and is encrypted using ATTLS, using the provided user provided RSA certificates. Once the data has arrived into DataGate, the Cloud Pak for Data security by security by design ensures that all the interpod communication, which is again it's all driven by Kubernetes. So the interpod communication is also encrypted using Cloud Pak for Data's RSA certificates. And this also includes the communication between DataGate and the DB2 target that's on the Cloud Pak platform. For the data at rest, all the data that is stored in the target database is encrypted using DB2 native encryption, which is FIPS compliant and NIST certified algorithms are used, all the good stuff. Bottom line is the data is safe. Also, when we say that the data in the platform, the target is encrypted, we mean it encrypts all kinds of data, including the table spaces, data in the table space, and even the transaction logs. So the next, let's move on to the next characteristics that again we all know is very important for enterprises: high availability. And since DataGate is built on the platform, high availability is already built in, because Kubernetes takes care of most aspects of high availability by being able to automatically restart failed pods. Storage, in the case of the platform itself, storage can be either network storage like NFS or Spectrum scale, or it can be local storage, host path. And using local storage also has other implications. Local storage just means that storage local to the pod where this DataGate service is running. And in case there is a disk failure, it can be tolerated up to the RAID's level of fault tolerance without an outage. In case of node failures, Kubernetes tries and attempts to bring it up on another node. But if the storage is local, that wouldn't be an option. The alternate solution to tackle failure situations would be to have a second DataGate instance on the same cluster. And in case of a container or a pod failure, the infrastructure will attempt to restart the pod automatically, and it would take an outage until the pod comes back online. Now to the, this is probably the, next couple of slides would be the most important, the secret sauce, as we like to call it, which is the integration synchronization and how it operates. So from the image here, you can see that there are two major players. You see the log data provider, which is on the left, and the log data processor on the right. So let's start talking about the provider itself. This component is built in to all DB2 V12 systems. There's no additional install that's required. And the provider is custom built with a laser focus on the current use case that we are talking about, which is move the data from DB2Z in the most atomic, consistent, and performant way into the DB2 for Linux target. And since it is built for this custom use case, it does what it is expected to do very well. Also, since it's part of the engine itself, it follows the same install, update, and support lifecycle of the engine with no additional steps required. The design ensures that the CPU usage is minimal and kept in check, and that the throughput is also higher. Plus, it's also nearly fully zip eligible, MIPS usage, zip eligible at about 96%. The log data processor, which is now on the right side of the image, is built into DataGate and follows the same life cycle of the DataGate itself. There's again no additional install or update required for this component. And since the install and update of DataGate itself would take care of maintaining it at the right level. So it is purpose built to process data, a purpose built processing engine that ensures, again, low latency and high throughput. And there have been multiple optimizations that have been made to enable switching between the bulk and the trickle feeds when needed, based on the frequency of the incoming data and frequency and volume of the incoming data. These two components work together to ensure that a transactional consistency protocol is maintained, where queries running against the data on data gate or on the target return the most recently committed data. Some more details about the log data provider, the internals itself is, again, all communication is through TLS and secure DDF. DataGate, the way it works between Db2z source and DataGate, which is the front end to the target, is DataGate frequently polls for data from the source. And whenever there is a new incoming request, a new SRB is started, and logs are read from the DB2 recovery log into the memory buffer, which totally avoids any disk IOs. And the SRB will remain active until replication has stopped or until no further fetch requests are received within 60 seconds. With DB2, there is also a new display command, display stats for the log reader. And from the output, I don't know, it might be very tiny. You can see a session ID, the session ID associated with this synchronization request, and the current position, the current log position that's being read, and the status in this case says suspended or end of stream, which means there's no more data to read. Just some communication, just some comparison between integrated synchronization as a technology and other similar technology. We've picked CDC in this case, change data capture, which is one of them that's out in the field that also is able to replicate data from DB2Z into other sources. And as you can see from the top and bottom, top being CDC, you can see most of the CPU cycles that is used by CDC is not zip eligible. And in the case of integrated synchronization, there are two differences. One is it uses only about 49% of the CPU time that's used by CDC. And also the second highlight is that most of that 96%, as we saw, most of that is zip eligible. That's, when we talk about zip eligibility, what that means is there is less MIPS consumption on the mainframe. Now the step about loading tables, and this is probably a continuation from the discussion we were having about the log provider and the reader. And now this is the way the table load happens. So, since the integrated synchronization is built and optimized specifically to enable synchronization of data from the source to the target, the load is highly optimized to maximize throughput, and while keeping the resource usage on the Z side low. For loading partitioned and segmented tables, parallel unload is effected on the DB2Z side to maximize the throughput. Segmented tables are unloaded sequentially when loading one at a time. And data transfer to DataGate is in the internal Db2 for zOS format. And the complexity of the conversion to the Db2 LUW format and the insertion into the target is all handled by DataGate itself. Also, one of the key things to note is that with the use of unload with isolation CS, the source tables are fully available and online during the entire synchronization process, and there is absolutely no outage on the source tables. They are available for reads and writes for the entire duration. And DataGate always converts everything into Unicode, since everything on the cloud is Unicode, and EBCDIC is of no use there. So this is some information about the loading. Now let's take a look at about synchronizing and accessing the data. And we saw most of this in the demo. I think this is more just the theory behind what we saw. Also, when adding tables, there is an option to enable the toggle, the enable synchronization and load tables, which can also be done as a separate step. All this can be done using the interface, and only the tables needed for the cloud-based applications need to be added and kept in sync using DataGate. All the tables that are loaded, of course, if the asynchronization is enabled, then we will make sure that data is transferred. Anything that gets inserted into the source will make its way into the target. On the target side, new user-defined tables can also be created to augment the source data to help gain new insights, basically applications, to drive applications. Connection to the target database is usually done using a simple JDBC ODBC connectivity using an authorized user ID. And when building applications, this data from the source, which of course is now in the target, can be combined with data from other sources, Mongo or any other database where you're bringing in data into the platform. You can combine all of that data together to gain useful insights, business insights. On the cautionary note, DataGate is built for and can only handle unidirectional data transfer between the source and the target, and not vice versa. So although users do have direct connectivity to the target that's running on the platform using JDBC and ODBC, the data, if the data is modified on the target, it will not be replayed back into the source. And what might happen is it might result in data inconsistency or data stability issues, and of course might lead to issues during the synchronization process if that is one of the the tables that was modified is one of the tables that's enabled for synchronization. And of course, we all love REST. And one of the advantages here is that most of the tasks that are driven from the user interface are handled under the covers by stored procedures, very similar to IDAA itself. And the interfaces, this allows for easy automation of stored procedure calls using DB2 native REST wrappers to be part of any a pipeline if that's something that your the organization has set up. And this will avoid the need to click around on things and do things manually. If automation is one of the things on the table, you could make use of automation with these as well. A quick note about the performance measurements. So we have tested in the lab against two system types. We do have Linux on bare metal and one Linux on Z. And this also considers both flavors of DB2, Target, OLTP, as well as Warehouse. And most of this configuration that you see here, and I'm not going to read this out, I'm sure you all will have access to the slides. Most of the configuration that you see here on the screen maps to what we call a t-shirt size large system. And we go by t-shirt sizes in mapping the configuration small, medium, and large, and this would map to a large. So what we have gathered is the load performance with this large t-shirt size configuration is up to, data loading is up to DataGate can handle up to 2 terabytes an hour of incoming data to be synchronized. And this 2 terabytes an hour includes the on-the-fly conversion from to Unicode as well. Now for the synchronization performance, we have classified this for both the platforms. Again, top Linux on bare metal and S390, which is Linux on Z. And we have workloads. We've been testing with workloads that are purely insert, purely updates, purely deletes, or mixed insert, update, deletes. And you can see for a updates take a little longer and hence a little lower throughput because updates are internally decomposed as inserts and deletes. And we have a maximum for 200,000 rows per second. We have, in case of inserts, we have an average latency of about 1.5 seconds and a max latency of about 2.8 seconds. In case of transactional, and in case of analytical, it is 1.3 seconds of average latency for the same workload size, and 1.8 seconds maximum latency, again, same workload size. So again, I will not read everything here. I did put this on the slide so that you if you're interested, you can go back and take a look at it later. So let's move on. Okay, so this is we are nearing the end of the presentation, and I didn't honestly plan for a full hour because I know it's hard for every one of us to sit through for an hour. So I think I'm keeping my time well. So we'll talk about a couple of release highlights and for that we had starting this summer. So one of the big ones was the query routing support, which I did show when we did the UI walkthrough, that we did release as a beta or a technical preview, and with the to provide the ability to route analytical DB2 for zOS queries to this DataGate instance and shift the query workload from processing on DB2Z to and also save processing resources, and in turn execute it on DB2 on the DB2 OLTP DB2 warehouse target. And one of the other big ones is the ability to update credentials for the DB2 log reader, which was one of the sections we saw when we did the edit source on the UI. You could do it on the fly. Earlier, before this 2.0 release, the synchronization flow had to be stopped to do this credential update. 201 is a fix only release. For 202, we do we introduced adaptive compression for row store tables by default. And the other one, which is also part of the acceleration use cases, is we introduced the support for archiving. And this is to archive data from DB2 for zOS to DataGate to reclaim disk space on zOS. And the archive data can still be queried on DataGate. It is just not no longer available on the source. Again, if you're interested, I have a link to the release updates to take a to take a look. We do have an upcoming release that's coming up with some more capabilities that are being introduced, and we could probably talk about it in another session. Now the last part is the support for the support itself, Linux on Z. And what is listed here is minimum requirements for running a cluster with DB2 and DataGate. On Linux on Z, we need a ZVM version 7.1 or later, at least 128 gig of memory, and at least 8 IFLs. The terabyte of DASD depends on the volume of data that you're going to handle, and also a high bandwidth network between the ZLPAR, where the DB2 source is, and the OCP cluster. Again, Linux on Z. The last one is we very briefly talked about, and I think in the first couple of slides, we talked about cloud support. So, it is on the public cloud. Um, we do support IBM Cloud, AWS Cloud, or even the support for Azure. So because AWS and Azure do have the ability to do managed OpenShift, and that is the means through which DataGate is also able to run on these platforms. So that does conclude the material that I had prepared to share with you guys today. And I hope I made I was able to explain, and what I explained made sense with respect to the underlying technology and the business case behind DataGate itself. And I really thank you all for listening. I have my name and email in here, so in case there are any questions, comments, or feedback. And this is a new technology, like I mentioned early, and this I would love to hear to see how this is coming across to our technical community. Yeah, and that again, I thank you all for being here and wishing you all a good rest of the day.
Thank you. That's really useful. So we do have a couple of questions in the chat. So does it work like CDC replication between DB2, zOS, and target? And does datagate sync depend on log reads?
Yes, yes. So DataGate does access the DB2 recovery log. And so, yes, it does depend on integrated synchronization depends on log reads. With CDC, yes, the technology is very compatible. It's just that in sync, CDC is a more generic technology. It can read from multiple sources and synchronize into multiple targets. But InSync is built specifically for reading data from DB2 zOS, since it's part of DB2Z, and synchronizing to a DB2 warehouse or an OLTP target. So this is built specifically for this flow. And I hope that answered the question.
Yep, and then there's another one. What happens to integrated sync process if a log no process like load or replace is run on source DB2 zOS?
So sorry, Sophie, you might have to repeat that for me.
What happens to integrated sync process if a log, it might be log number rather than log no, process like load or replace is run on source DB2 zOS?
I would have to get back on that one.
Okay.
Yeah, I would have to get back on that. So is it possible for you to give me, send me?
Yeah, I can send that across to you.
Okay.
Okay, that's what it is. It. Okay. And then probably more of a comment than a question was that if you need Kafka at target, then from DB2 source, you need CDC. So comparing the cost is a little tricky as Datagate does not provide data into Kafka target end. So I guess that's more of a comment on.
Yeah, no, I think, no, that's a good comment. And thanks for that. So we are learning as, we talk to more customers, we are learning that Kafka is, one of the things that many enterprises are looking into, and we are, figuring out how this whole flow works with it. And yeah, so that's definitely something to keep in mind.
Okay, cool. And it looks like that's everything in the chat. We haven't got anything more. So I think with that, we'll close the session off. So thank you so much for giving that session. That was really useful. And the code for this session is 4AV. So please do go and give feedback. And that's the one. And the next session is in half an hour at past. So we've got a little break now.
Okay. Thank you, Sophie. Thank you all.
Thanks. Bye.
Bye.